Hello everybody, quick review for the last quiz of the year. There are 14 questions on the quiz and it's pretty identical to this review. Really only number 13 on the review is what's not on the quiz. So you're given the formula to figure out a sequence, so you plug in n equals 1, n equals 2, n equals 3, and n equals 4. Don't just see the plus 7 and assume you're adding 7. So this will get us 9, and then 11, 13, and 15. When you're asked to find a specific value, just take that subscript, of course, s for n. So we have 2 times 21 plus 7, so this will be 49. Now this is a negative 52 here. Hopefully your paper's fixed. It says we're trying to find what term number negative 52 is. You, of course, could just start at negative 3 or at 3 and just keep subtracting 5 and keep track of how many times it takes you to get there. Or you could use the formula. You'll be given all the formulas. This, of course, is the explicit formula for arithmetic, which is a sub n is equal to a sub 1 plus n minus 1 times d. So we know that the answer is negative 52, and the first term is 3, plus we want the n, that's what we're solving for, and of course this is negative 5. So distributive property from the right-hand side, 3 minus 5n plus 5, so that's 8. Subtract the 8, we get negative 60 equals negative 5n. So we're looking at the 12th term. For number 4, you're going to have a problem like this. This is a two-step problem. If you want to use the sum formula that's on the paper, it's not too bad, really. We're adding up the first 12 numbers, so 12 over 2, and then you take that times the first term plus the last term. They tell you what the last term is. So that formula on the paper is easy to use, but you do have to figure out what a sub 1 is. It wouldn't be that hard to figure out what a sub 1 is. We just need d. So to find d, we're going to take the numbers, the actual answers, so the numbers that are in the sequence, 90 minus 27, and then we'll divide that by their position in line, subtract that. So we get 63 over 9. So the difference is 7. So we're adding 7 each time. So you can work backwards. You could set this up and use the summation formula, completely up to you. So if we have to go back backwards to a sub 2 would be 20, a sub 1 would be 13. So it is pretty easy to figure out. So we could just put the 13 right in here and you could figure it out that way. Or if you really want to use the summation on your calculator, now we need the explicit form of this sequence. So 13 plus n minus 1 times 7. So 13 plus 7n minus 7. So for the summation form, n would go from 1 to 12 of 7n plus 6. And you can put that in the calculator and work it out to be 618. Either way, should get the same answer. Now there is one story problem that's sort of, oh my, I don't know what's happening. There is one story problem. That looks like this. This is, sorry, I don't know what happened. I don't know what's happening. Okay, sorry about that. There is a story problem that you'll have to just get the gist of the problem here. So we're starting 3 miles on the first day, and the total would be to get to the 26.2, not to get further. He increases his distance by 0.8 miles each day after. How many days until he gets to a full marathon? So we know that the answer, 26.2, is equal to the first term, 3, plus n minus 1 times 0.8. So 26.2 is equal to 3 plus 0.8n minus 0.8. So we get 26.2 is equal to 0.8n plus 2.2. When we subtract 2.2 over here, you end up getting, divide by 0.8, you end up getting 30 days. I guess in a problem like that, you could take a half a day. It could be an extra portion of a day. A day can exist in a fraction. Now we're going to switch to geometric. So a sub 8 is equal to the first term, 6 times the ratio, 1.2, to the n minus 1, which is 7. Throw that in the calculator, we get 21.5. For this ratio, it's 6 over 8, which is 3/4, or 0.75. I would check it again. Pick two more numbers, 4.5 over 6. I would just check it. I know it tells you that it's geometric, but honestly, I would check it. You should be able to believe. Oh, wait, I'm looking at should be able to believe the sequence. So s sub infinity of first term divided by 1 minus 0.75, that works out to be 32. Now for number 8, a couple different ways you can do this. The answer it's been corrected on your paper. I'm just going to try to think through this a little bit logically rather than trying to force a formula. We've got the second term at 45, third, fourth, fifth term at negative 12, 15. So you're going to multiply by r, multiply by r, multiply by r. So you're going to multiply by r to the third. So if you divide those out, if you take negative 12, 15 and divide it by 45, and then take the cube root of that answer, you end up with getting a negative 3. So the ratio is negative 3. So when you divide by negative 3, a sub 1 is 15. So now we get that a sub n is equal to negative 15 times negative 3 to the n minus 1. Now, honestly, there is a problem just like number 9. Pay attention. They give it to you straight up like this with the sigma form and everything. Pay attention to where it starts, where it stops. Make sure you get the same letter in your sigma. This just is 1092, but it is 3 repeating, so please include that repeating bar. You'll be asked to write one in sigma notation on your own. So figure out if it's arithmetic or geometric and use the appropriate explicit form. This one has a difference of 3, so of course that makes it geometric. If you can come up with a pattern on your own, then you don't need the formula. I'll show you the formula. A sub n is equal to first term plus n minus 1 times 3. So 6 plus 3n minus 3. So the summation form, and you cannot answer the question. It doesn't tell you to find it. We start at 1, and with the dots, we're going to infinity. So that's not something you can put in your calculator. It does not say find the answer. It just says write in sigma notation, and it'll be similar to that on the quiz as well. Not something you can answer. So here we have to find r. Of course, we know that r is negative 3. And the explicit formula for this geometric sequence is a sub n is equal to first term times negative 3 to the n minus 1. Recursive and explicit. Make sure for recursive you give both parts. That didn't happen all the time. Didn't happen on the embedded assessment all the time. So a sub 1 equals negative 18. And it does look like we have a difference of 11. And then so a sub n is equal to the term before it, a sub n minus 1, plus 11. Explicit, because it's arithmetic, we're going back to that same old formula, unless you can think through it. Negative 18 plus n minus 1 times 11. 11n minus 11. So our explicit form here is negative 29 plus 11n. So you'll have to do both of those with one problem just like that. Now, honestly, this number 13 that there's really nothing like on the quiz. This problem is a little bit strange. You have to kind of make some assumptions. I would use, of course, because we're looking at arithmetic sum, I would use the arithmetic sum formula. So the answer, 5510, is equal to n over 2. Oh, sorry, but it is 10. We know there's 10 prizes, 10 over 2. And then we have two numbers. We have no idea. So this, of course, is a 5. So when you divide both sides by 5, we get 1102 is equal to two numbers added together. Well, don't divide by 2, right? Because that's not really going to work. We know that probably each one has to end in a 1 because there's $100 difference. So that's the zeros are at the end. And so now we're at $1,100. So you could split up $1,100 a lot of ways. I'm going to try 101 and 1101. And then if you work through it, it'd be 101, 201, oops, hello, 301. So you could go back and sort of think through it a little bit. But this is a little bit much. And so we're at 10. So then the 10th one would be 1101 right there. So we can work through it like that. Oh, I'm sorry. I went too far. It's 1001. I circled it. I don't know why I kept going. My fault. There will be 2 problems like 14 and 15 to find this infinite sum or to state that the sum does not exist. Of course, this is all about R. So make sure you find R. This one looks like we're multiplying by 5. So this does not exist because R is too large. R is greater than 1. Here, the value for R is -1/2, so that's allowed. So our infinite sum is -1/4 over 1 minus -1/2. And so we get -1/6. And that is the whole quiz, honestly, if we take off number 13.